Hello everyone, this is Group 33. My name is Ziyu Wang.
My name is Zhenghao Wu.
My name is Tuode Huang.
My name is Zawei Wu.
So our project is Pothole Killer 2000 Pro.
Our professor is Jennifer Archison, and our advisor is David Miller.
We just give you a quick overview of what we are going to talk about today. We are going to define the problems that we are facing. Then we are going to give you the proposal of our solution, talk about the drawing date we have in analysis, and then we will talk about the methods that we are using in this project, and then we will end up with a review.
Potholes continue to torment Philadelphia citizens' life for a long time. It not only damaged cars, causing property loss, but also threatened lives. Last February, the auto group called Pax Brothers responded to 17,000 flat tires caused in Philadelphia's county. And according to the group, most of these causes of the flat tires were pothole related. Nowadays, the Philadelphia Streets Department uses the machine called Pothole Killer 2000. However, after watching Pothole Killer 2000 operate, we identified some weakness. By eliminating these weaknesses, we expect to fix the potholes in a more effective and durable way. So the Pothole Killer 2000, it is carried with a truck, which means if you want to purchase these devices, you have to purchase the whole truck. It's kind of expensive for like small cities, and the potholes it fixed cannot last longer than 2 years. So our project target is to make this device smaller, and it can be put on any truck, and it will be cheaper so that any small cities can purchase that. And the potholes, after it fixed, it can last longer than 2 years.
We separate the work to 5 steps: clean, heat, fill, smooth, and clean again. Each step uses a tool to do. One key thing to mention here is the heating step. To deoxidize the surface of the pothole will help the new material to have a better adhesion with the older material so that the patch has longer life. This is a view of our project specification table. And our project standards.
I'm here to talk about the design description. What we have changed due to this pandemic is that we have moved from physical prototype to an electrical design, which is a lot easier than actually making a physical copy of it, but which is a lot harder because if we're doing a physical copy, we can see how the parts combine together and like how everything functions. Is it well or not? And our design consists with 7 parts, which are the base box to contain everything in it, a portable power station, which can power everything inside the box, and a torch or gas tank, which is used to deoxidize the surface of the pothole, and a vacuum machine, which is for cleaning the pothole and vacuuming everything, sucking everything out of the pothole. A robot arm, which is used to deliver the torch and the vacuum nozzle into the pothole, so the vacuum and torch can do their work. The cement mixer is a drum which holding the cement, and it will keep it rotating to keep the cement from solidifying during transfer. And we have a dispensing rail to dispense the cement into into a pothole. And smoother it's the same design as the robot arm, but at the end, rather than two nozzle, it will be a fan like machine which can rotate and smoothen out the surface of the pothole after we have added in the material of it. The base box will be a box that is 1 meters width by 1 meters length by 40 centimeters high box without a lid, and is made out of stainless steel sheet. And it can hold everything inside, so when you lift it up, it won't bend apart. And a 330 watts portable power station will be our main primary power source of our product. And this power station will be able to charge during parking and using an outlet, and also a solar generator which can generate power during the transfer. It will be able to output 110 volts AC and 12 or 10 amp DC, depends on the needs. The torch will be a nozzle that's connected to the gas tank by a rubber tube. The nozzle will be placed at the end of the rubber arm, so the arm can reach down into the pothole and let the nozzle put out flame and deoxidize the surface. The gas tank the size of the gas tank depends on the needs. Like if you need a bigger gas tank for a bigger pothole, you can add that, or you can use a smaller one if you're dealing with a small pothole. And the gas tank need to stay at a low temperature, so we will add a heat insulation blanket on it so that it won't get overheat during transfer, like while in the summer. We also have a vacuum in our system. Small debris inside the pothole is larger than the normal dust inside our house, so we need a more powerful vacuum in order to deal with this problem. Normal vacuum only has a RPM at about 25,000, which can only generate a suction pressure at about negative 20 kPa. But our design is using a very, very strong suction motor, which can generate many times more suction pressure than the normal vacuum machine did, which is able to suck out everything inside the pothole. And robot arm is the key assembly to our project. The vacuum tube and the torch are attached on the robot at the end of the robot arm. It's controlled by a 2D simulator software on the laptop. The robot arm has a total weight of about 42 kilograms. The length of the main arm is 1.5 meters long. There was 2 of those arms to make sure the arm can easily reach the ground. The total torque of the robot arm is about 10,000 Newton times centimeters. The position of the arm are all 90 degrees to each other and make it largest torque at the connection point with the arm and the box. The reason why the robot arm is important is that the smoother at the end will be using robot arm as well. Further detail will be demonstrated at data analysis section. The cement mixture of our product will be very similar to the one that's commercial used. The cement mixer of our product used has a capacity at about 35,000 cubic centimeters. Most of the pothole that needs being fixed, it's about 50 centimeters by 50 centimeters and 10 centimeters depth, which is about like 12,000 cubic centimeters. So, but it's just a rough estimate. So with our full load of cement, the Pothole Killer 2000 Pro will be able to fix 1 to 4 pothole per trip. And the motor will keep the drum rotating during traffic, so the cement will not solidify. A smoother is our last step of our fixing process. It's the same design as the robot arm, like with 1.5 meters long arm, But at the end, rather than a torch and rather than two nozzle, it will have a fan which will be rotated at about 40 rounds per minute to like smoothen the surface. And the fan has an angle, tilted at an angle, so it can swipe out the excess summit. As for the methods of our product, steel is our main material. The box, the cement mixer, the base of the robot arm will be made. Most of the part will be made out of steel, and carbon fiber material is for robot arm because it's durable enough and light enough. So the rotating of the arm will not need that powerful motor. And as for the end part of the torch and the vacuum, we will printed 3D printing parts to deal with that. And for our full model, we are made out of cryoparametric. Here is our graph and drawing for our product. The top left is the free body diagram of our robot arm and how the force is acting on it. And the middle top one is the cement mixer, which we are added it into the base box. And the top right one, it's the smoother. And the bottom left one is the robot arm. And the bottom right picture, it's the picture that we add everything into it and how it looks like on a truck model, which is very rough. On the left side, it's a detail figure of a robot arm, and it's labeled which arm is it. And on the right side is a table which showcases the detailed dimension of the robot arm. The torque of a robot arm is calculated at a 90-degree angle, so it's a maximum at that point. It's a maximum. So our motor that is rotating the arm just needs to have enough torque, just the one that is maximum, to rotate it. So it's easier for our calculation and to find the suited motor for that arm. And here is our final drawing of our product, which we see on the previous slide. The truck model is just to showcase the dimension of our product and how it will be looks like after we installed it. So it will sit on the trunk bed on the back of the truck, and the robot arm and the dispensing rail is retrievable. They can fold apart inside the box. So the box has a space at about 1 meters by 1 meters by 1 meters high. And on the top left of the box, there's empty space. That's for your storage and the gas tank, also the vacuum machine to sit.
For economic, this machine product is at downstream economics. The target market of the project is government and construction companies. Currently, the cost of the prototype is estimated at about $1.7 thousand. For environmental, this project may have adverse effect on the environment, cause the material and the manufacture processing. For example, the manufacturing process of the stainless steel is unfriendly to the environment. Reduced pothole means improved pavement behavior, which will be conducive to extend the life of the tires and decrease the tires amount used. And then the environment also can benefit from it, because the scrap tires are unrecycled and noxious. For social impact, assist to the Potholes killer work only one time within a period of time, rather than 2 or 3 times now, which means the government does not need to repair the potholes frequently, and the money will be saved from this project. So the government can use the money for other projects, such as common facilities renovation, which contribute to promoting the quality of the life of the citizens. Additionally, a long period of time for Potholes is conducive to people's quality of life, such as driving experience. Also, driving experience is a teeny thing. Drivers spend an average of 2 or 3 hours to go to work and go home every day. If the road keep smoothing, driving will not be stressed out about driving in potholes before beginning to work. That can potentially promote people's work efficiency. After whole day work, the mood of the drivers also can be improved if the road is not bumpy. For ethical, the first priority of the product must be safety on using, so the machine is designed to control and use as easy as possible to ensure the workers' safety.
The challenges of our project. The most challenging thing is that the focus point has shifted during the process. Before the pandemic, the focus point is the prototype, assembling how the robot arm works, how to keep the cement liquid. Testing was supposed to be the next focus point. All of a sudden, we have to shift the focus point from prototyping to detailed drawings and data analysis. The data are even all by simulation. This is the biggest challenge of our project. The conclusion of our project. We have halfly done the prototype. Haven't get a chance to test it yet. We have done detailed drawings and data analysis as shown above. Furthermore, we have fully understand the concepts of the projects and we have find the direction for future work. Learning experiences. Prototyping and data analysis are two totally different things. Prototyping is physically saying while data analysis is visual imagination. Secondly, never underestimate the difficulty of anything. An example is originally we thought the material that is used to fill the potholes will just be a bacterial mixture with asphalt. Then throughout the process, we changed it to the asphalt only. Then we got to figure out how to melting the asphalt. Then we finally changed it to cement. We still got to deal with how to keep the cement liquid. And this is only a very small part of our project. So never underestimate anything. Lastly, just follow the steps one by one, and eventually things will come out smoothly. The recommendations for the next year senior. The recommendation for the next senior is early. 3 earlies. Find the teammates early, know what you want to do early, and find a stakeholder early. Time is the biggest enemy during the process. 1 year goes just like a snap. Future work. There are several things that can be put into future work. First, find a stakeholder. Currently, the project is self-funded, so a stakeholder will be a boost. Secondly, testing the prototypes. Testing was supposed to be the focus point this term for us. It has to be put into future work due to the pandemic. Thirdly, finalize the dimensions of drawings. Finally, take more things into consideration, such as how to maintain the whole patch, how the wires are connected, and how to make the control panel and so on.
Here is a review of our final project budget, around about $1.7 thousand including shipping.